Alright, in the previous video, we talked about inverse functions, and we talked about what they basically are. And remember that an inverse function is basically the opposite of a function. We looked at this in terms of graphs and tables, and so now we're actually going to go ahead and talk about finding inverse functions algebraically and also checking them. Alright, so let's go ahead and talk about how do we find an inverse function. The first thing that we're going to do is we are going to go ahead and replace f of x with y. And then from there, we want to go ahead and switch our variables. Remember, inverse functions, inputs become outputs, outputs become inputs. And so basically, we want to exchange the variables, x's with y's and y's with x's. And finally, we're going to go ahead and solve for y. We do want inverse function, and so we're going to replace y with f inverse of x. All right, a couple things that we do want to note is that if a function is not one-to-one, you can put restrictions on the domain to create a one-to-one function. For example, if we are looking at a quadratic function, which is a parabola, we can restrict the domain to just the right side of the parabola. It's now one-to-one, and we can find an inverse function. A couple other things to note is if we have application problems. When working with application problems, certain variables represent certain concepts. For example, we usually use lowercase t to represent time, capital V to represent volume. And so when we find the inverse function, we do not switch the variables. We still want them to represent what they represent. Instead, what we do is when we find our inverse function, we switch the variables in the function notation. So for instance, if we have a function c of t, where c represents cost and t represents time, when we find the inverse function, we write it as t of c, meaning that c represents our input, the cost represents the input, and t represents the output, or time represents the output. Now, some of this stuff we have talked about in previous courses. The new thing that we're going to add is we want to be able to determine if two functions are inverses. And in order to do this, what we do is we use composition of functions. We have if f of g of x is equal to x, and g of f of x is equal to x, then f of x and g of x are inverses. Again, remember that when looking at tables, we have f of a equals b turns into f inverse of b equals a. We switch our inputs and we switch our function definition. F becomes f inverse, inputs become outputs, outputs become inputs. All right, so these are going to be some of the things that we play around with in this section. All right, so let's go ahead and look at some examples. And for these, we're going to do a couple different things. We want to start by determining if our function is one-to-one. If it's not, we're going to restrict the domain. We have one example of this. From there, we want to find the inverse function, and then we want to identify the domain and range of our inverse function. Finally, we are going to verify that our functions are inverses by using composition of functions. And that's going to be kind of the new thing that we do in this course. All right, so that's a lot to do, so let's go ahead and jump into it. All right, we're going to start with example A. And the first thing we want to know, is it 1-to-1? All right, so this function is 1-to-1. This is basically our basic cubic function, which remember has this snake shape. And all we've done is we have shifted it 5 to the right and 2 up. We have not changed its basic shape in any way. And so it is 1-to-1. All right, the next thing that we want to do is we want to go ahead and find our inverse function. And so for our inverse function, remember the first thing that we're going to do is we're going to get it out of function notation. So I am going to rewrite this as y equals x minus 5 squared, cubed plus 2. I want to swap my variables, so I want to replace my y with x, and I want to replace my x with y. And then we want to go ahead and solve for y. So in order to do this, we're going to basically go backwards. I want to subtract my 2. I want to isolate my cubic. To get rid of a cube, we take the cube root of both sides. And then finally, to get y by itself, we're going to add 5 to both sides. And so we get the cube root of x minus 2. We do want to make sure it's very clear that our cube root ends after the minus 2. And then we have plus 5. And finally, we want to replace our y with our inverse function notation to denote that this is not just some random equation. This is our inverse function. All right, so when we talk about domain and range, okay, so for f of x, we have a domain of all real numbers. It's a cubic. And for our range, our graph also goes forever up and forever down. And so it is going to be all real numbers as well. And so when we talk about the inverse function, we flip them. And so my range becomes my domain. And my domain becomes the range. We do want to be very careful here, though, and just make sure that we know which one's going to where. So, domain becomes the range, and range becomes the domain. All right, the last thing that we want to do is we do want to verify that our functions are inverses, and we're going to do this by using composition of functions. Okay, so this is how it works. I am going to figure out what is f of f inverse of x. So we want to plug in our inverse function to the original function. All right, if we do this, we get, I'm going to plug this whole thing in to my x, and then we simplify. So we get the cube root of x minus 2 plus 5 minus 5 cubed plus 2. And so in my original function, this is what we were replacing x with. And then now we want to go ahead and simplify this. And so a lot of this is, basically things should cancel out. So for instance, we have our plus 5 and our minus 5 cancel. This becomes the cube root of x minus 2 cubed, and we still have our plus 2 on the outside. And we get that our cube root and our cube cancel, leaving us with x minus 2 plus 2. And finally, our minus 2 and our plus 2 cancel, and we are left with this is equal to x. That is what we want. We want to see that they completely cancel out. Okay, now we do need to repeat the process, but we are going to do it the other direction. And so if we do this the other direction, we want f inverse of f of x. All right, this means that I want to plug in my original function to my inverse function. All right, in order to do this, we are going to take this whole thing and we are going to plug it in for x in our inverse function. All right, so what does this look like? What we get is this is equal to the cube root of x minus 5 cubed plus 2. And then we still have our minus 2. All right. And we still have our plus 5 on the outside. Okay, so if we start canceling, we get our plus 2 and our minus 2 cancel. This is equal to the cube root of x minus 5 cubed, and we still have our plus 5. All right, we cancel our cube root and our cube, and this is equal to x minus 5 plus 5. And our minus 5 and our plus 5 cancel. And so we are left with, this is equal to x. And so when we compose it the other way, we do get the same answer. All right, that takes care of the first one. Let's go ahead and look at a couple more. All right, we're going to come over to example B now.
like my life is devoted to the animal world, Nationwide is devoted to their members, protecting what's important at every stage of their lives. That's why Nationwide and I have been partners for over 30 years. Learn more about Nationwide at nationwide.com. Scary movies always start with the heroes traveling somewhere they'd never expect to find danger. Of course, I'm the hero in this story. What do you expect? It's my show. During a trip to the Fiji Islands in the South Pacific, Sue, our daughter Julie, and I booked a tour of Bird Island. We couldn't wait to get there. For a few hours, the tiny uninhabited island would be like our very own tropical paradise. I wish it wasn't raining, but that's the way it goes.
So beautiful.
Oh, I know. When we reached the beach, our guide Micah began pointing out the nesting seabirds, and for a moment, the island felt a little less gloomy. But we had no idea what was slithering around inside the forest.
Oh my God! Oh my gosh! Yeah, look at that snake. Huge sea snake. Scare me to death.
What we saw is called a banded sea crate. Not only does it look creepy, it's one of the deadliest creatures of the sea.
Michael, how come the sea snake comes up on land?
To just the food and change skin.
Okay, let's see.
In the 6 weeks, we go for another new skin.
Golly dang.
Michael, what do they eat, did you say?
No, gray yellow on the reef.
Oh, they eat
The yellow.
eels. Every time they eat, they have to come up on
Come up
land?
and land and just
Every time?
every time. In the
Interesting.
pool.
That was neat.
Right.
This is like something out of a scary movie.
Shoot.
That's the dead one, and this is the live one here.
Wow, look at that. Hey, Mike,
Okay.
you see another snake, tell me. I don't want to step on it. We're in the middle of it. Watch out, Julie.
That's not funny.
I'm gonna tell you something. I get chills right now. I really am.
Oh my gosh, they're here. Look at this. They're everywhere, girls. Look at this. Oh my gosh, there's another one. Look at this. They're everywhere.
No way. Oh,
Oh my gosh,
no!
look at that. Look at this, the biggest one. This is the biggest one. God, hey, look at this. Look at, hurry. Look at this thing. This thing must be 8 feet long. And this is the creepiest place. Just like in the movie, snakes everywhere. Like this was like a setup. It is not a setup. This is nature. This is actually nature.
This is another first experience.
Well, it really
for
is.
sure.
It is. It's one of the top 10 for me. I mean, I've never, this is a top 10 natural experience for me. Next, a surprising close call with one of Africa's biggest and toothiest predators. Sue and I traveled to Chobe National Park in Botswana during the dry season. It's considered the best time to visit because giant herds of herbivores congregate along the river. Our guide and boat captain was Dr. Clay Wilson. So we're going to see a lot of animals?
We're going to see lots of animals.
All right.
Close up and personal.
During a drought like this, thirsty animals are easy pickings for the river's massive reptiles.
Crocodile.
Whoa,
We're going to get close to some big boys.
bigger than that?
Oh, yeah. We'll try to work on your first heart attack.
No, let's don't do that. A little ways up the river, we came across a big Cape buffalo that was staring down a crocodile on the shore.
Be interesting to see what he does.
Is that thing alive?
It's a lot. They come out this time of the day they're reptiles to regulate their temperature.
Now his eyes are open.
Oh, no, he knows we're here. He's just not worried about us. Yeah, look at this
Oh.
buck here.
Wait a minute, where'd he come from?
Let's see what goes right.
Gosh, you have to be on your toes all the time.
Oh, yeah. And they'll disappear in a heartbeat.
There he goes.
You won't see them until they grab you.
These living dinosaurs are supremely adapted hunters. It's believed their jaws produce a bite force that's similar to a T-Rex, and their tails are so powerful they can launch their entire bodies out of the water.
Oh, that's a big one.
Wow.
When we saw a giant croc on the riverbank, I figured we'd give it some distance. So what are we gonna do? Go up the shore where it is? Oh my gosh. His eyes are wide open.
Golly.
You think we should have them both going up that way?
No, we're fit.
Okay. Against my better judgment, Clay maneuvered the boat to get us as close as he could. It was unsettling to be at eye level with such a huge predator, but we couldn't pass up the photo opportunity.
He's relaxing. He's not going anywhere.
After a few minutes, I gotta admit, we all began to relax as well.
You see the sable out there? Out in the distance there?
Oh, gosh, yeah.
Whoa. Let me tell you, that's the last time I get cozy with a crocodile.
We all got one right there.
Coming up, this is one of those deadly snakes in the
Yes,
world.
of the world actually.
Plus the blooper of the week. Next, Wild Countdown. Welcome back to Wild Countdown. I'm Jack Hannigan from base camp at Columbus Zoo. As always, no animals were harmed while filming today's show. I wish I could say the same for my pride and my heart. So far, we've been surrounded by sea snakes in Fiji. It's like something out of a scary movie. We had a near miss with a Nile crocodile. Whoa. Next up, a night hike to a rainforest that could have been my last. About 3,000 feet above sea level, Ecuador's cloud forest is one of the world's biodiversity hotspots. As night fell, our guide Carlos led Sue and me to the heart of the rainforest, where anything could be hiding around the next bend. Well, one thing I see why they call it cloud forest or rainforest. Well, listen to all the sounds of the jungle.
Whoa! What's that?
Whoa!
Holy mac, what's that?
We run into a group of researchers who found a bushmaster, the longest venomous snake in South America. Who is that man they're messing with?
He's herpetologist. He works with amphibians and reptiles.
This one of those deadly snakes in the
Yes,
world.
of the world actually.
It's the first one we've seen in a while, isn't it, Sue?
Yeah, it is. What happens if this snake would happen to bite you?
Oh, first, it affects your blood cells. So
You would
you
hemorrhage?
will have, you will hemorrhage. And your heart will stop also.
Ay, ay, ay. So this snake knows that we're here.
The snake knows that we're here right now. Yeah, it's feeling our heat actually right now.
So when you walk around the jungle, you've got to be very careful.
Look,
That
there's
you
a
don't-
hole. It's very difficult to see it.
Well, that's it. I mean, look at that camouflage. It blends in so well with just
Right.
even our surroundings here.
Usually they are nocturnal, so they will go out at night and are hunting.
Oh, they are nocturnal. So they would hunt in the rain?
They will hunt in the rain.
When Carlos told us that the bushmaster's fangs are over an inch long, I decided not to push my luck.
So like this?
Yeah, like this. Huge.
Could he bite through my rubber boot?
Yes, he can just put your fangs and you
Okay.
can just go straight
Yeah, I
into
was
the...
going to say with
Yeah,
things
I'm
that...
sorry, we're too close.
I didn't hear him bite through the boot.
Yeah.
Let me just end this right now because I'm going to leave here before he puts the snake up, okay?
Okay.
A bushmaster. See you later. I hope I don't see you later. You always got to be on the lookout for venomous creatures in the jungle. You might also encounter them in one of the world's largest cities. More than 19 million people live in and around Sao Paulo, Brazil. While you might not think much wildlife could survive in this concrete jungle, the local spider population is booming. Since Brazil is home to some of the world's most venomous spiders, I was anxious to visit the spider lab at the Instituto Butantan. They say there's 15,000 spiders in this little building. To me, that's amazing. Most of them are banana spiders like these right here. Look at this. Never seen buckets and buckets of spiders. The reason they have such a large collection is so they can produce antivenom, which requires the help of a whole lot of spiders. Now this is something I've never heard of or never seen. Milking a spider for its venom. That's very important. We don't do it with snakes, but spiders cause a lot of bites here in Brazil. Wow, they just suck the venom right out of his fangs right there. Good night. Want me to do it? I do one? No, dangerous. Yeah, no, didn't think so. According to the technicians, it takes 5,000 delicate extractions to collect just 3 milligrams of banana spider venom. Fortunately, most of the Institute's spiders are less dangerous, but no less infamous. You know, a lot of times when we think of spiders, we think of the tarantula. Look at this one here. Look at the fangs on this thing. Look at that. Ooh. In spite of their size and reputation, the tarantula's venom is weaker than a honeybee's, so they're not considered harmful to humans. But they are strong. That is a mad tarantula. back. Let me have it back. I literally cannot pull this away from this. Man, if you can. I'm gonna put this thing back. Hey! Help me. Somebody take this thing. Man. Thank you. Whew. Now that's a creepy place. What is the difference between venomous and poisonous? The answer is coming up next on the Wild Countdown. Luxury should be stress-free, right? Find your next vehicle at Land Rover Shreveport, where it's our mission to be the automotive home for online drivers in the greater Shreveport metro. Our pressure-free shopping experience, paired with the most luxurious inventory Shreveport has to offer, takes the stress out of purchasing a car. The way this process should be. Stop by our showroom today or visit us online. LandRoverShreveport.com.
When you can breathe better, what isn't better? DACC continuously works to help prevent asthma attacks. So girls' days are better. Game days are better. Even Mondays are better. DACC's an add-on treatment for specific types of moderate to severe asthma. It's not for sudden breathing problems. Dupixent helps people with asthma achieve better breathing that lasts. Some people felt their asthma symptoms improve in as little as 3 days. Isn't that better? Severe allergic reactions, including skin reactions, can occur. Get help right away for face, mouth, tongue, or throat swelling, wheezing, or trouble breathing. Tell your doctor right away if signs of inflamed blood vessels like rash, chest pain, worsening shortness of breath, brown or dark-colored urine, tingling or numbness in limbs. Tell your doctor of new or worsening skin symptoms, joint aches and pain, or a parasitic infection. Don't change or stop other treatments without talking to your doctor. Do more with less asthma. Ask your doctor about Dupixent, the most prescribed biologic in asthma.
Who's the master?
This is your moment in the spotlight, right?
Rangers don't have to look for trouble. Trouble finds them. This party's good. This party's good.
What I do. And the winner is.
What is the difference between venomous and poisonous? Venomous creatures inject their toxins with a bite or sting. Poisonous animals carry their toxins on their skin or inside their bodies, so they need to be touched or eaten for their poison to take effect. Welcome back to Wild Countdown. I'm Jack Hanna here at Base Camp McClovis Zoo. Today's thrilling and chilling stories are campfire worthy. You know, it kind of makes me want s'mores. There was a time we crossed paths with a venomous bushmaster. Whoa, holy Mac, what's that? This one of those venomous snakes. Yes. In my visit to a research lab that was crawling with creepy critters. Look at the fangs on this thing. Look at that. Ooh. Next, tonight I risked life and limb to search the Amazon for a stealthy reptile, all in the name of research. The caiman is a crocodilian cousin of the American alligator, the gigantic saltwater crocodile. In Peru, the Amazon River tributaries are the perfect environment for these cold-blooded carnivores. On land or in the water, they'll slowly approach their victim without a sound, and then lunge, snapping their jaws down on their prey. As the sun set, I joined Eric, a wildlife researcher who was trying to estimate the caiman population in this region.
Now, which is very dark, so it's the best time to see the caiman activity because they're feed at night, mostly at night.
Fully grown, this species of caiman can grow over 7 feet long. And at that size, they prey on wild pigs and even deer.
Look at there.
Come on, look at this. Is that a baby gator?
All baby.
The only way to determine how many male and female caimans were in the river was to inspect each one.
Get down, I'll get this from here.
Yeah, the right side is better. The right is muddy.
You want to slip?
Yeah, maybe. Very close. Down, right there. Down. Okay, look.
Here's something you want to pass?
Yeah.
You see how fast it is?
Yeah.
You think it's well, that's a practice run.
Look at this guy. This is the
it look like it's wearing glasses or spectacles.
Look at this.
So beautiful.
Although the caiman is a deadly carnivore, there are even more dangerous hunters in the Amazon, humans. In the 1980s, the spectacled caiman was considered a threatened species. Fortunately, American research has shown the local caiman population is rebounding.
Every year we can get more and more caiman because the people are not hunting anymore.
So how did I do on my first research trip? Good, huh?
Yeah, very good, very good, very
Thank
good.
you very much. I'm gonna put him in the real land, okay?
Yes, there.
Here we go, watch this.
I think we hunt very fast. Yeah.
Look at that. Isn't that beautiful or what? Put yours up there like that, they join each other. Thank you. That was neat. I'll come back and do another census someday.
Okay, now next time you will play by yourself, a big one, eh?
Coming up,
That's amazing.
plus the blooper of the week. Next, Wild Countdown. Just like Wildlife is devoted to the animal world, Nationwide is devoted to their members, protecting what's important at every stage of their lives. That's why Nationwide and I have been partners for over 30 years. Learn more about Nationwide at nationwide.com. Welcome back to Wild Countdown. I'm Jack Hanna. Let's take another look at the thrilling and chilling encounters on today's show. Number 6, a spine-tingling tiptoe through a haven for sea snakes. 5, an invigorating shower courtesy of a 12-foot crocodile. 4, a walk in the moonlight with a venomous pit viper. 3, a struggle with a surprisingly powerful tarantula. And 2, a nighttime sentence of slippery swamp dwellers. Next, a terrifying tour of a foul-smelling, roach-infested bat cave. On the Southeast Asian island of Borneo, there's no shortage of exotic animals. To find the country's spookiest creature, my wife and I headed nose first to the Golangtan Cave.
I smell, but it's guano. Smell that? Take that in.
All right, for example B, the first thing we want to know is our function one-to-one? This one it is a basic rational function. It has one vertical asymptote, it has one horizontal asymptote, and so we're okay there. The only time that we would get in trouble is if we start having x squareds running around. All right, so let's go ahead and find our inverse function. So again, the first thing we're going to do is replace f of x with y. We want to flip our variables, and so we get x equals, and wherever we see an x, we're going to plug in a y. So we get 3y over y plus 1. All right, so now let's go ahead and solve for y. The first thing we want to do is we want to get rid of the fraction. And so I'm going to go ahead and multiply both sides by y plus 1. On the right side, my y plus 1's cancel. All right, from there we want to go ahead and distribute. We get xy plus x equals 3y. Remember, the goal is to solve for y, and so the next thing that I want to do is I want to go ahead and get all my y's on one side and my non-y terms on the other side. And so I'm going to go ahead and subtract x from both sides. I'm going to subtract 3y from both sides. And I'll explain why when we get to our domain and range problems. All right, if we do this, what we get is xy minus 3y equals negative x. We are still solving for y, so the next thing I want to do is both of my terms on the left have a y, so we can factor it out. And now we have y times something, and so in order to get y by itself, I'm going to divide by the something. And so we're going to go ahead and divide by x minus 3. Y has now been solved for. We get negative x over x minus 3. And we're going to replace y with f inverse. All right, so that is my inverse function. Okay, we want domain and range for each one of these. And so let's talk about our f of x. F of x, to find our domain, we want to set the denominator equal to 0. And if we do that, what we get is x equals -1, and we put not equal to. All right, let's find our domain for the inverse function. The domain for the inverse function, again, we set the denominator equal to 0 and solve, and we get x equals 3. But because we are talking about domain, we are talking about this from a not equal to standpoint. All right, so now here's the thing, is remember that domain becomes range, range becomes domain. And so for instance, for my inverse function, I know what my range is going to be, is I'm going to take my domain for my original function, and I'm going to replace the x with a y. So we get y is not equal to -1. Similarly, we can find the range for the original function. We take our domain for the inverse. It becomes the range of our original function. Okay, so domain becomes range, range becomes domain, and vice versa. Our range has to do with the horizontal asymptote. And so for our original function, if we look at the leading terms, what we have is a horizontal asymptote of y equals 3. That's the same thing as our range for basic ones. For our inverse function, if we look at our leading terms and simplify them, we do get -1. And so, again, we have a horizontal asymptote of -1. That's the same thing as saying the range is y is not equal to -1. All right, so that takes care of that. Now, the last thing that we want to do is we do want to try to compose the functions. I'm just going to do one of them. To me, if we show that our domain and range are opposites, or that they are interchanged, that's enough. I'm not going to expect you to do this on homework or quizzes or exams, okay? But just to show you kind of how does this work. So let's go ahead and bring our functions down again. All right, we had f of x equals 3x over x plus 1. And we had our inverse function was -x over x minus 3. Is that right? Yes, it is. Okay, so now let's go ahead and see what happens when we compose these. All right, we're going to just do one of them. We're going to do f composed with f inverse. All right, so if we do this, we're going to take our inverse function and plug it in for x. Okay, so what we get is we get 3 times negative x over x minus 3. And I'm just going to say divided by negative x over x minus 3 plus 1. Okay, so basically what I've done is I've taken, instead of dealing with complex fractions, I'm taking my division bar and I am turning it into a division sign. I have plugged my function in for my x's. And so on the top we get 3 times negative x over x minus 3. And my bottom becomes negative x over x minus 3, and then I still have that plus 1. All right, so now we want to go ahead and simplify this. Okay, so the first thing I'm going to do is the numerator, this first thing, I'm going to move the 3 up to the numerator, and we get negative 3x 3. On the other side, I want to combine this into a single fraction, and so I am going to multiply by x minus 3 over x minus 3. And what we get is negative x plus x minus 3 over x minus 3. We simplify. The first one is okay. The second one, we want to go ahead and combine our like terms. And what we get is negative 3 over x minus 3. We are dividing fractions, and so we do want to go ahead and flip this. We're going to change our division to a dot, and we are going to flip our second one. And then we want to cancel. So we can cancel x minus 3's, we can cancel the negative 3, and the only thing that is left is x. And so we have f of f inverse of x equals x, which is what we wanted. We should go ahead and do the other one, but as I said, now that you kind of see the process, you should be able to go ahead and do that one on your own. All right, we have one more example that we want to look at. And so our last example is going to be example C. Again, the first thing I want to know is this 1-to-1? And the answer is no. And the reason that this is no is because we do have this x, we have this squared on the outside. And if we graph this, what this is this is a parabola that has been shifted 1 unit to the right. It does not pass the vertical or the horizontal line test. Now that doesn't mean that we just throw it away and say can't be done. What we can do is we can restrict it. And so what I'm going to do is I am going to go ahead and restrict my domain. to just the right side of my parabola. So I'm going to say let's do x is greater than or equal to 1. And so visually what this does is it gets rid of this side of my parabola, and now it is 1 to 1. Since it is 1 to 1, we can go ahead and continue. Okay, so we're going to go ahead and find our inverse function. We get y equals x minus 1 squared. We flip our variables. And we solve for y. So I am going to take the square root. Now generally when we take the square root, we include plus or minus. And we can't do that here because then we run into issues. We're going to have, it's no longer going to be 1 to 1. Because I restricted my domain to x is greater than or equal to 0, and we're looking at just the right side of the parabola, I'm going to keep the positive square root. If we finish solving for x, we want to, or for y, we want to add 1 to both sides. And what we get is the square root of x plus 1 equals y. And we replace our y with our inverse function. And so what we get is f inverse of x is equal to the square root of x plus 1. All right, we want to know what is the domain of our inverse function. And our inverse function is x is greater than or equal to 0. All right, if we look at our restricted domain up here at our graph, what is our range for this thing? And our range is y is greater than or equal to 0. And so notice here that my range of my original function corresponds to my domain of the inverse function. And so we can do the same thing. What we can do is my domain for the original function, we restricted it to x is greater than or equal to 1. And so for my inverse function, my range is going to be y is greater than or equal to 1. We flip our domain, we flip our range. And if we graph the inverse function, this is a square root. It has been shifted up 1. And so it basically looks like this. We do have the condition that it is symmetric about the line y equals x, and so we are done with that. All right, the last thing we want to do is check using composition of functions that these are inverses. All right, so we have f of x equals x minus 1 squared. And we have f inverse of x is equal to the square root of x plus 1. All right, if we compute f of f inverse of x, we are going to plug f inverse into our original function. So wherever we see an x, we are going to replace it with square root of x plus 1. All right, so what this becomes is we have our parentheses. We replace the square root of x with, we replace x with the square root of x plus 1. We still have our minus 1, and we have our square. All right, we can cancel our 1's. This leaves me with the square root of x squared. And then we can cancel our square and our square root, and we get that this is equal to x. All right, now we're going to go the other direction. We want to go ahead and find f inverse of f of f. And for this one, we want to plug the original function into the inverse function. And so here, wherever we see x, we're going to replace it with f of x. All right, so what is this equal to? What we get is the square root of x minus 1 squared plus 1. All right, my square root and my square cancel. We get x minus 1 plus 1. And then my minus 1 and my plus 1 cancel, and I am left with equals x. And so what we do have is that for both of these, we get x, and therefore we can say that algebraically, yes, they are inverses. All right. That takes care of finding inverses algebraically and also the composition of functions. That's going to be kind of the new thing that we look at in this course, is we do want to practice this composition of functions to show that they are inverses. All right, the last thing that we're going to do in this section is we're going to apply our concept for inverse functions to formulas or to real-life application problems. The primary thing that we do want to remember, first off, when we find our formula or find our new equation, is we do not use inverse notation formula. Remember that our letters represent certain things, and we don't want to change that. And so we're going to flip our function around. All right, we're going to start with one that we are all pretty familiar with. And so what we have is we have the formula for the circumference of a circle. And so we want to find the inverse function. All right, so the first thing that I'm going to do is I am going to take this out of function notation. Instead of c of r, I'm just going to make this a c. We do want to solve for the other variable. We're not going to flip them. We're going to go ahead and solve for the other variable. Input becomes output. Output becomes input. And so if we solve for r, we're going to want to divide by 2 pi. All right, so what we have here is c over 2 pi is equal to r. And we do want to put this back in function notation. Now here, what we have is c is my input, which means that c is what goes in the parentheses. And when we plug in c, what we get is r. So my inverse function is going to be r of c. And this is equal to c over 2 pi. All right, the second thing that we want to know is what does the inverse of c compute? So for instance, when we look at our original function, what we're told is this is the circumference of a circle with radius r. And so when we talk about the inverse function, we kind of need to reword this. What we are going to be given is the radius of a circle given the circumference. C. And so here we are plugging in our circumference, and when we plug in our circumference, this equation tells us what the radius is equal to. All right, let's go ahead and look at one more example that's a little bit more complicated. The second example we have is going to be this one. All right, it says the formula W of H approximates the recommended minimum weight for a person H inches tall. And we do have some domain restrictions. This is for H between 62 and 76. Okay, so let's go ahead and look at some of these questions. First one says, what is the recommended minimum weight for someone 70 inches tall? And so 70 inches tall, is this W or is it H? This is going to be an H value. And so we can go ahead and plug this into the original formula. And so if we do this, we get W of 7D, equals 25 over 7 times 70. I'm going to put that over 1. Minus 800 over 7. All right, I'm going to go ahead and multiply this. If we do 25 times 70, we should get 1750. If we subtract 800, we get 950. And if we divide that by 7, I get approximately 136 pounds. That is rounding up. All right. Now, this is stuff that we've done previously. Okay, so now we want to go ahead and find our inverse function. And so for our inverse function, we are going to start with our equation. I am going to take it out of function notation. And so instead of WH, I'm just going to rewrite this as W. All right, we want to find the inverse function. So we want to solve for H. The first thing that I'm going to do is I'm going to go ahead and multiply both sides by 7. And what this does is it gets rid of my denominators. Leaves me with 7W equals 25h minus 800. We can add 800 to both sides. We get 7w plus 800. And then we want to divide by 25 to both sides. If you want, you can separate this out, but I'm not going to. And so what we get for our inverse function is h of w equals 7w plus 800 over 25. All right, let's go ahead and do a couple things here. Let's start off with what does the inverse compute. So remember that the other one computed the weight for a person 8 inches tall. And so here, what we're looking at is it computes the height of a person that weighs W pounds. We could get more specific on this, but to me, it's just a matter of making sure that we interpret what does H represent, what does W represent, and which one is the one that we're plugging in. All right, let's go ahead and we're going to do 2 more things here, okay? The first one is, let's go ahead and evaluate and interpret H of 150. Okay, so you can do this one of 2 ways. And I'm just going to do one way. Okay, we're going to evaluate H of 150. We have our H formula. And so if we plug this in, we have H of 150 equals 7 times 150 plus 800 divided by 25. All right, if we simplify this, we get 7 times 150 is 1050. If we add 800 onto that, we get 1850. And if we divide by 25, we get 74. Okay, so we do want to interpret this. And so just a reminder that the number inside is a W. We are finding H, and so what this is the height of a person weighing 150 pounds is 74 inches. All right, the last thing that I do want to talk about, and it didn't come up in any of the problems that we did, but for instance, we did have that domain restriction up at the top where H is between 62 and 76. And I don't know if we're going to see it, but One of the things that we might need to do is also establish the domain restrictions for the inverse function. So let's go ahead and see how do we do that. Well, in order to do that, what we're going to do is we're going to come back to our original function, w of h equals 25 over 7, h minus 800 over 7. And these are our restrictions that we have right now. 62 is less than or equal to h is less than or equal to 76. Okay, to find our domain restrictions for our inverse function, all we're going to do is plug in these two numbers. Okay, if we figure out what is w of 62, well, we get 25 times 62 minus 800 over 7. Basically what I did there was I just combined this into a single fraction. And if I use my calculator to go ahead and calculate this, what I get is w of 62 is approximately 107. And so we're going to go ahead and put that in here for our domain restrictions. We're going to have 107 is less than or equal to w. And then we want to find the other one. And so if we plug in 76, same thing. We're going to multiply 25 times 76. We're going to subtract 800. And divide by 7. All right, so if we do this, we get 25 times 76 is 1900. If we subtract 800 from that, we get 1100. And if we divide by 7, we get w of 76 is about 157. And so there are domain restrictions for the inverse function, and that is how you find them. All right, that finishes off our discussion on inverse functions. The next thing that we're going to be moving into is exponential functions. And a lot of this is going to be review, but we are going to be kind of just upping the difficulty level a little bit from what we looked at last semester. All right, let's take a quick break and then we'll come back.